Greetings and welcome, students. This is our last video on the 5 main chemical reaction types, and today we are going to be doing predicting double replacement reactions. As you can see on the screen now, my steps are all here, all 4 of them. Does it work? Take care of the outer ions combinations, the inner ion combinations, and then balance the whole thing. You can also see an example that's kind of sketched out below, and we're going to do a few more in just a minute. But right now, take a screenshot if you have to, because this is what we're going to be dealing with, and we're not really going to be keeping here. Right below, you can see the solubility grid, which tells you whether something will be aqueous or whether it will be a solid once it reacts. Remember, in order for a double replacement to work, it has to not be double aqueous. So there must be a solid, a liquid, or gas that is made, but not double aqueous. That doesn't work. So here we go. We're going to go through 3 double replacement reactions. The first double replacement reaction we're dealing with is actually a doozy, reacting aluminum bromide with ammonium phosphate. Now remember, ammonium is that polyatomic positive cation that exists at the beginning of a compound. And behind it, you will see phosphate, another polyatomic ion. So in this case, we're dealing with 2 polys and how they're reacting. First thing we need to do, and you may notice I have underlined your outer and your inner ions that are going to be combining to make our products. So we need to see, does aluminum phosphate work? Will the outer aluminum and the outer phosphate combine to make something that lasts? And you can see it does. Aluminum phosphate is indeed a solid. That is exactly what we want to see. As such, we know that the number 1 reaction will work. Since it will work, we are going to deal with the outer ion combinations first, and then the inner ones. So for the outer combinations, we have got aluminum and we have got phosphate. So that is going to be what we write down first. So I'm going to click over here and make sure that everything I have is set to the right size. So when we do this, we are going to have aluminum, which is Al, and phosphate, which is PO, and it will need a little 4. Normally subscripts do not carry over, but because it is part of a polyatomic, it will. So just make sure you carry subscripts over if it's part of a polyatomic ion. Now, we are going to have this joined by our inner ion combination of ammonium and bromide. Now remember, the positive one must go first. So we're going to have ammonium go first and bromine go second. So when we do this, remember the ammonium gets that little 4 that is there. So I want to make sure that I have it there. Now, fortunately for us, aluminum and phosphate are +3, -3, so they cancel. And ammonium is +1 and bromine is -1, so they cancel too. So both of these are put together exactly like they need to be, which means we have to now balance. Now remember, a pro tip for balancing, if you have something as huge as this ammonium phosphate, probably a good idea to start with that and deal with the ions separately. So we're not going to separate the N and the H's. We're going to do NH4 as if it was one thing. We're going to treat it like ammoniums. So at the reactants, we have 3 ammoniums. In the products, we have 1 ammonium. So I'm going to make that a 3 with my coefficient. So now my ammoniums are fine. My phosphates are 1 in the reactant, 1 in the product. So that's good. If I then check the others, 1 aluminum to 1 aluminum in the reactants and in the product. So we're good. 3 bromines in the reactants, and now that we put a big 3 there, 3 bromines in the products, which means we are done. Now, sometimes you may have to mark whether something is, a solid, liquid, or gas, and if we did that, the aluminum would be our solid, but, I didn't ask you to, so you don't have to in this, but some cases you will. That is the precipitate, that will be the solid. Now let's take this idea and move on to number 2. Number 2, we have sodium fluoride and magnesium chloride. Again, notice that the outer elements have been marked and the inner elements have been marked. I need to see if this will work, so I take a look. My outer ones is sodium chloride. I go down here and I see that sodium chloride is aqueous, so we don't know that it's going to work just on that. So we must check the inner one. Magnesium fluoride. So I go to magnesium, over to fluoride, and there we go. We've got our solid. So because magnesium fluoride will work, we're good. It will have an actual reaction that will give an actual product. But in this case, it was the inner ones, not the outer ones, that actually worked. It just happens. It's, about 50% of the time. But we still should do the outer ones first, which would be sodium chloride. Now, in this case, the sodium and the chloride are not polyatomics, so they do not carry over subscripts, but they are +1, -1, so at least that makes our life a little easier. In addition, we then have to make sure that we put our plus there because we are now going to get a new compound. This compound is going to be magnesium fluoride, and magnesium fluoride has the +2 magnesium with the -1 fluorines, which means, unfortunately, we do need to put a little 2 there with the fluorines so that it becomes canceled. So that way we have a +2 magnesium and 1 -1 fluorine, another -1 fluorine, and boom, +2 -2, all done. Then we balance. Since we know this works, since we've got everything canceled, let's do that. 1 sodium, 1 sodium, cool there. 1 fluorine, 2 fluorines, okay, not so cool. So I'm going to sit there and put a 2 in front of that. Because I did that, I also really should put a 2 in front of my sodium chloride. Oh, that 2 is a little high. I'm going to lower it slightly. There we go. Then 1 magnesium to 1 magnesium, 2 chlorines to what is now 2 chlorines, which means we are good. So let's take a look at the last one we have here. We have got sodium bromide with barium hydroxide, and we want to see if it works. So let's look at the outer ones. Sodium hydroxide will be what it makes. I go to sodium, I go down here to hydroxide, and no, it's aqueous, so that doesn't help us. Let's see if barium bromide does. As I go to barium and to bromide, and ooh, that doesn't help us either. Well, if both of our products are aqueous, then it doesn't work, which means we write NR. As this will not actually finish reacting, it'll just go over and over and over again, making no definite product. Nothing drives the reaction, nothing makes the product. So that's how we do double replacement. Now, real quick, if you were to ever be asked which is the precipitate, that would be whatever the solid is. So if we went back to our first question, that precipitate was the aluminum phosphate. That was the thing that actually made a solid that drove the reaction that actually happened. So we could mark that with a little S so that we know that that is. Whereas in the other one, when we did that, it was actually the fluorine here, the magnesium fluoride, and normally you wouldn't be writing over something, but quite frankly, it's the end of the video anyway, and I just wanted you to know that's how you show if something is a precipitate. That's it. Predicting double replacement. I hope you have a good day and stay safe. Take care.